So we want to talk about inverse trig functions because we use, inverse functions undo functions in some sense, if you remember, right? So if a function takes an x value and sends it to y as a reminder, inverse functions take the y and send them back to x. And so if we want to solve an equation, we need to know inverses. That's how we do that. Right? That's how we solved exponential equations and logs, right? Because those are each other's inverse, and we used one or the other to solve the other, right? So like if we had a log, we change it to an exponential. If we have an exponential equation, we take a log. And so we need inverses to solve equations is what I'm trying to say. And so we need to know about these inverse functions so that if we have an equation that has a sine or a cosine in it, we know how to solve that equation. That's the whole point of inverses, aside from just their interestingness. Okay, so that's my reminder about what inverses are, right? They send y values back to where they came from. But if you remember from the last test, if we want an inverse, we need a one-to-one function. How do we know that, if we look at this graph of sine right here, how do we know sine is not one-to-one, visually speaking? What's going on visually? There's some test we can do that can tell us what it is. It's the horizontal line test, right? This function and cosine as well clearly fails the horizontal line test. We could draw a horizontal line and it would touch more than once. And so sine as a whole doesn't have an inverse, but what we can do is we can focus in on just one piece of the function, and so that's what's being shown here in red. You might not have that color, but I'll draw the line here anyway. If we focus on the piece of the graph between my two pen marks, and we cut that graph, so just what's in between my two hands, right? That piece right there. That piece is one-to-one. And so let's cut that piece, and we show it right here. So we cut off the ends, and we're just focusing in on one little piece of sine that is one-to-one. And now we have an inverse of this piece, right? This graph now is one-to-one. And so we have an inverse of that thing. And so that's how we can even talk about an inverse sine, is by cutting off most of it and focusing in on just one-to-one piece, right? We need to have a one-to-one piece. Does that make sense? Any questions about that? Yeah. It does look like an odd function. And that's because sine is odd. Let me take out that part of the notes real quick. You kind of barely touched on it in one of these sections. Here it is. So on page 73, if you notice, we said that sine, cosecant, tangent, and cotangent are odd. So you're absolutely right, this is an odd function. And some of the other ones, secant and cosine, those ones are the even ones. Yeah, that's a good point. And you'll see that on the next page, so just kind of like looking towards the next page, that looks more like an even function. Although, anyway, it's a little misleading when we talk about that, but you're right, it is an odd function. But notice what we did. Let me just point this out first. When we made this cut and we focused on this piece, that piece only exists between minus pi over 2 and pi over 2. And that's what this says right here. And so whenever I'm thinking about these problems, I usually draw my unit circle. And if we're talking about sine inverse, we only want to think about between positive pi over 2, sorry, that should be plus pi over 2, and minus pi over 2. So we only think about the right-hand half of the unit circle when we're talking about this inverse. Right, we focus in on that side. And you'll see what I mean. When we talk about answers, we want to make sure that our answers are on the right-hand half of the unit circle. And then if we want to see the graph of the inverse, this is the graph, right? And remember how we can get from the original function to the graph? we take the original function and we reflect it around the line y equals x. So if we took this function and we flipped it over that line like this, it would look like that right there. All right, and so this is what the inverse actually looks like. I know those two things kind of look similar. If you just kind of glance at those two graphs, they almost look the same, right? But notice how this one's kind of flattening out. And so if we flipped that, it wouldn't be flattening out, it would be going up, which is what this does right here, right? So they are different. And notice how also the bound switch, right? So the x values became the y values, and the y values became the x values, right? So that's another visual confirmation that those two graphs are each other's inverse. Questions so far? All right, so let's solve one of these. We've kind of got two flavors of problems when we talk about these kind of problems. We've got these ones on the left-hand column and these ones on the right-hand column. And let's start with the left-hand one. So, we see that sine inverse has domain minus 1 to 1, right? You can just look at the graph. Look, the domain of this thing is only between minus 1 and 1. And we can see that the range is between minus pi over 2 and pi over 2. Again, just look at this graph. You can visually confirm the range and the domain. And then we have this relationship, right? This is the definition of an inverse. So if sine takes a t and sends it to the y, then the inverse takes that y and sends it back to the t, just like any other inverse function. And so when we see a problem that looks like this sine inverse of negative 1 kind of looks like this half, right? And so we want to know what this equals. We want to know what t that equals. And so we think about it by doing this. We think, where did that t come from? Right, so I'm going to rewrite this equation, which looks like this. Right, those two things look similar. And I'm going to write it in this form, which gives me something to work with. Right, so here's how we think about this. We think sine of t equals negative 1 for what value of t? Right, think about why that's how we think about it, right? The inverse is taking the y value and sending it back to the t. So when we write it like this, we think, where did that t come from? What would I have to plug into sine in order for it to give me negative 1? Right, that's how we think about it. Does it make sense? That's what this statement, that's like what's going through our head. Sine of t, what do I have to put in for t that will give us a y value of negative 1? That's how we think about it. Let me pause and let you just ponder that for just a moment. Questions before we keep going with that one? Okay, so if we want sine to be negative 1, that means we need the y value on the unit circle to equal negative 1. Because sine is the y value, right? Where does that happen on the unit circle? Yeah, down here. Right? That happens right here. Does everyone see that dot? Maybe I'll make it a little bigger. I don't know if it's coming out very well. Right? That's the place on the unit circle where the y value is negative 1. And so there's many places that we could write down that would tell us that. I heard someone say 3 pi over 2. What's another place that would put us on there? Is that right? No, not 6 pi over 2. How about a negative 1? Negative pi over 2. 7 pi over 2 is the next one. That's probably the one you were thinking of. Right, so there's lots of values that would put us on that spot. But we need to pick one that's between minus pi over 2 and pi over 2, because that's the piece that we're thinking about. And so let me write that down before we get the answer. I'm trying to be very detailed about that. So we want the y value to be negative 1. This happens at lots of t values. At t equals 3 pi over 2, minus pi over 2, 7 pi over 2, etc. Right? There's infinitely many different t values that would put us on that spot. And so the question is, and wait, let me just go back. Each one of those t values corresponds to a different piece on the graph. Right? This graph keeps going in both directions. Remember that? And so, 3 pi over 2 is this one right here. Does everyone see where I'm pointing with this? This value of -1 is associated with this t. 7 pi over 2 would be the next one. That would be like this one right here. Minus pi over 2 is the one we want because that's the one that's on the red part of the graph. And so we need to pick one of these values that's actually on this piece. And so that happens to be the minus pi over 2 one. Right? So let me write that down. Since we need t to be between minus pi over 2 and pi over 2, we choose the one I circled, the minus pi over 2 one, because that's the only one that's in that interval. And so the inverse, sine inverse of -1 is minus pi over 2. Now, that was a lot of words. I was trying to write down and be detailed about how I was thinking about that one. You don't need to do that every time, of course. But I want to be kind of clear about if we start with an inverse question, how do we think about that, right? We think about where did that -1 come from, and that came from plugging in minus pi over 2. Questions? All right, so that's one flavor of these kind of problems. I want to jump over to the right-hand column and look at this one. Is everyone else set with this piece? I got to slide it over a little bit. You sure don't have any questions? I'd really love to answer a question. All right. So let's look at this one. The ones in this right-hand column, go ahead. Nope.
So, is it always going to be that same chunk of the...
Yes, we're always thinking about the interval from minus pi over 2 to pi over 2 with sine inverse. You'll see, just kind of jumping ahead to cosine real quick. What we do with cosine is we think about 0 to pi. And so that's the top half of the unit circle. And so with sine, we only think about the right-hand half, because look, the right-hand half have all unique y values, right? All the y values are unique there, but the x values are not unique there. They're the same right here as they are right here. And so that's why with cosine, we talk about the top.
What about the left side?
We could do the left side.
Okay.
We could. We're just trying to do one convention and just talking about the same piece every time, so we're on the same page. Yeah, you're right. We could think about the left side if we wanted to. Where would the left side be in this graph? So, the right side is cutting this piece right here. What would the left side be? It would be from pi over 2 to maybe 3 pi over 2, right? And so that might be from right here to right here. So the left-hand piece would be what's in between my hands right there. Anyway, we just and it's it's a different shape and it looks differently. So just as a convention, we're talking about that piece with sine. Yeah, that's a good point. Other questions like that? So the other flavor are these kind of problems. And notice, does anyone recognize this at all? So this says when we plug the inverse into the function, they cancel out and we get x, provided we're on the right interval. And this says when we plug the function into the inverse, they cancel out and we just get x out. Again, provided x is on the right interval. Do these left-hand things look familiar to anyone? They're a throwback again to the inverse section. Do you remember? Say that again, sorry. Oh, yeah, they're composition of functions, absolutely. So we talked about this right after the composition of function section and in the inverse section. So you're absolutely right. It's the composition of functions, and this is actually this is called the inverse function property. This is that question that a lot of people had trouble with. It was the very first multiple choice question on the last test that very few people got right. So I guess I'm not surprised it's not in the forefront of your mind. But anyway, that's what the inverse function property says. It says when you plug the function into the inverse or vice versa, everything cancels and you just get whatever's inside them out. But since we're talking about these non-one-to-one functions, we need to make sure we're on the correct interval. That's what these properties are telling us, right? Okay. And so what about this first one? This looks like the second property, right? We've got the sine function inside the inverse. That looks like this. And so those things are going to cancel out, and we'll get minus pi over 4 as long as minus pi over 4 is between minus pi over 2 and pi over 2. That's what this property says. And so my question is minus pi over 4 in that interval? So is minus pi over 4 between minus pi over 2 and pi over 2? Question mark. Yes? It is, right? If we were talking about minus pi over 4 on the unit circle, we'd start at 0 and we'd go down to right here. This is minus pi over 4. And so it is on that interval. And so those two things do cancel. And so my answer is yes. And so that means that this answer is straightforward. They just cancel out. And we just get minus pi over 4. But we just need to double check to make sure it's on the right interval. Questions about that one? All right, let's do the next one. So what about this one? This looks like the first property, right? We've got the inverse inside the sine. And so this says those two things cancel out as long as whatever x is between minus 1 and 1. And so what's the issue with this one? It's 5, which is not in that interval of minus 1 to 1. And so we could say, let me use a different color here. We could say 5 is not in the range of the inverse, minus 1 to 1, I mean the domain of the inverse, excuse me. And so let me just point out, like, what happens if we tried to calculate that in the first place? Can we even find sine inverse of 5? Judging by what we did over here, right, this is sine inverse of minus 1. If we wanted to do sine inverse of 5, that's a 5. Sorry, that's bad handwriting. Not sure I ever have good handwriting. Anyway, if we want to do the inverse, sine inverse of 5, we think sine of what gives me 5? Nothing. You can't get a 5 out of sine, because what's the biggest sine ever gets? 1. So the max of sine is y equals 1. And so that's why this problem fails. So sine of t of 5 is not possible. And it depends on how they want you to answer it in the homework. I think they want you to say, like, does not exist, maybe. So that's why this problem doesn't work. You can't do sine of sine inverse of 5, because sine inverse of 5 doesn't make sense. You can't plug a t into sine and get 5 out. Yeah, so if this was 5 sine inverse of negative 1 of 5, then you could do something like that. But since it's not, you can't, right? So if you add some complexity, so you're talking about like a stretch, right? If you stretched it, if you increase the amplitude, absolutely. But as this is written, it's not stretched, and so we can't do it like that. Yeah, good point. Other comments, questions? Let's just roll with this last one. We might as well, since we're making moves here. What about this one? So this again looks like the first type. Yeah, it looks like the first type, right, where we've got sine inside there. And they'll cancel as long as x is between 11 pi over 4. I'm sorry, as long as 11 pi over 4 is between minus pi over 2 and pi over 2. And so, is it? It's not, right? 11 pi over 4 would be 11 steps of pi over 4, or we could think about it as 2 3/4 pi. And so if we were on this graph, that would take us all the way around and then another 3 steps. 1, 2, 3. So that's like over here. All right, so let me draw that. Let me write that down here. All right, so 11 pi over 4 is not in the right interval. Right, instead, it's over on the left-hand side of the graph. Right, that's where 11 pi over 4 is. It's on the wrong side. But it has the same y value as something that is on the correct side. Right? What has the same y value that's between minus pi over 2 and pi over 2 that has the same y value as 11 pi over 4? So 11 pi over 4 is right here. It's a pi over 4 type. What's this type right here that is on the same height, that has the same y value? Pi over 4, yeah. And it would be, that would be between minus pi over 2 and pi over 2. And so let me write that down. So 11 pi over 4 doesn't work, but 11 pi over 4 has the same y value as pi over 4. And pi over 4 is in the correct interval. Do I have enough room to write this? Yeah. Which is between minus pi over 2 and pi over 2. And so, do I have enough room? I should have enough room. So sine inverse of sine of 11 pi over 4 is actually the same thing as sine inverse of sine of pi over 4. And that fits that property because pi over 4 is in the correct interval. And so those things cancel out, and we just get pi over 4. So to summarize, 11 pi over 4 wasn't in the right interval, but we related it to something that was in the correct interval that has the same y value. So we needed to just shift it a little bit and think about a different piece, and then you can use that property, those things cancel, and that pops out. I want the one, if you can do it, so like, this one you couldn't do because it didn't exist, but if it's possible, I would want the one that's in the correct interval. Now, if you happen to use the property and you popped out 11 pi over 4, I would recognize that you knew what the property was and you did the math, semi-correctly, but just not in the right interval. So you get ample partial, you get most of the points if you didn't translate it to pi over 4. But I'm just trying to be very consistent, and that's the way that the homework's going to want it too. It's going to want those values between minus pi over 2 and pi over 2.
So the answer is pi over 4.
Pi over 4.
Okay.
Good.
So, what would the question to these problems be?
It would be this. It would say, is there an answer? And I don't remember what it says in the homework. It'll say something like, if there is no answer, enter blank. I don't remember what it is off the top of my head. I think it might be DNE, for it does not exist. But sometimes it wants something different.
My question was like, what would
It would just be like evaluate the following function or something. Evaluate the following expression.
So these problems are all inverses, right?
What do you mean by that?
They're only an inverse.
Oh yeah, the ones on the, well they're all already inverses. So they're all inverse type questions. Yes. But you can see the way we think about them sometimes is by relating it back to the original, right? In this one, for example, it was an inverse question, but the way we think about it is by thinking about it in terms of their original function. You want to do this last one today? Yeah, sure, let's do this last one. We've got some time. So we want to know what this equals, right? It equals some t. And so we want to think, I'm not going to write as many words. I'm going to be thinking the same thing, right? So we want to think sine of what gives us pi over 2. What would I have to plug into sine that would give me a y value of pi over 2, right? This is the y value. And we want to think of one that's on the correct interval. And so first of all, before anyone answers it, what type of points have this y value, square root of 2 over 2? Pi over 4 types, right? And so it could be, so our options are, it could be pi over 4, it could be 2 pi over 4 would be pi over 2, so it could be 3 pi over 4. It could be minus 5 pi over 4. It could be minus 7 pi over 4, right, etc. Right? There's lots of points that it could potentially be. But we want the y value to be square root of 2 over 2, and these are all different types of points that would give us that. Right? Just to be clear about that, if we look at the unit circle, we want to be at either one of those two places. That's where the pi over 4s are, right? And so some of those put us on the left-hand side, some of us put on the right-hand side, but only one of those is in the interval from minus pi over 2 to pi over 2. And so which one is it? This one. This is the only one that's in the correct interval minus pi over 2 to pi over 2. And so that's our answer. So sine inverse of root 2 over 2 equals pi over 4. Because we're sending it back to where it came from, right? Which is, the other way of saying that is when we plug in pi over 4 into sine, we get root 2 over 2. So we're sending it back there. Yep.
So similar to with this, how you can't cancel them out if it's not in that, like you can't solve them if it's not in the range here.
Mm-hmm.
If there was like a negative 5 there instead.
On this one?
Or on yeah, or on either of them, it would be solvable.
Yes, if there was a negative 5 or anything bigger than 1 inside an inverse, we wouldn't be able to send it back because we wouldn't know where it came from. Because nothing gives us something bigger than 1. Absolutely. Other questions? So what we had talked about last time was the inverse sine function, right? And the inverse sine function, just as a quick reminder, what we did was sine is not 1-to-1, and so we cut out a 1-to-1 piece of it. We looked at just the 1-to-1 piece, and it turns out that 1-to-1 piece is only between minus pi over 2 and pi over 2. And so we're going to do a very similar thing with cosine, except we're talking about the x values now, because cosine are the x values on the unit circle, right? And so we'll have to think about a slightly different piece of the unit circle, right? But we're going to do the same thing because cosine is not 1-to-1, right? If we drew a horizontal line through it, it fails the horizontal line test. And so we cut out a 1-to-1 piece, or cut out the piece between my pen lines right there. So we cut it, and it looks like that. And so if we cut out just that piece between my hands, that is a 1-to-1 piece, and that's the 1-to-1 piece that we're going to focus on and talk about the inverse with. But notice that, again, the interval is different, right? So instead of being from minus pi over 2 to pi over 2, our interval for our cosine inverse is from 0 to pi. And so now we're thinking about, on the unit circle, from 0 to pi, which is the top half of the unit circle. Right, so 0 is the start, pi is halfway around, and so we're talking about the top half of the unit circle when we talk about cosine inverse. And here's what the graph looks like. You don't necessarily need to know too much about the graph, but it's nice to just see it. And something I'll point out again from last time is that the domain of the original function is the range of the inverse and vice versa, right? The range of the original function is the domain of the inverse. Because they're inverses, they switch those two things. Okay, very good. And so this relationship is the same relationship we saw on the last page, except on the last page, sine is the y value, right? So sine was the y value, and so the inverse sends the y value back to where it came from. In this case, cosine is the x value on the unit circle, and so we want to send the x value back to where it came from. But it's the same thought process. We do the same kind of things, except we think about the x value, okay? Let me just point out, too, I forgot to mention this yesterday. Sometimes you'll see different words for this. So cosine inverse is sometimes called arc cosine, or which is abbreviated arc cos. And you'll see that sine inverse is sometimes abbreviated arc sine, or arc sin for short, right? So just be aware, and I think this comes up in the homework, or actually it comes up in the review problems at the very least. You'll see it called arc sine and arc cosine instead of cosine to the minus 1. And I put that note on that piece of paper, but I just wanted to sort of mention that out loud here. Okay, great. So let's look at this problem. So if we want to know cosine inverse of minus 1, that looks like this situation, right? We're sending the x value back to the t value. And so in order to solve this problem, we want to write it like this and think about where did it come from. So that we write, okay, the way we think about this is we say, what do I have to plug into cosine to get minus 1 in the first place, right? If we want to send it back to where it came from, let's think about where it came from. So cosine of what equals negative 1? So for what value of t? That's the question. And so we want to know the x value, right? Cosine is the x value. And so we need x to equal negative 1, because cosine's x. And so that happens on the unit circle, over on the left-hand side of it, right? Yeah, at pi, very good. It happens right here. That's the point minus 1 comma 0. And so this is the point where the x value is negative 1. It's the only point where the x value is negative 1 on the unit circle. But there's more than one option. I know someone said pi, and that turns out to be the correct answer. But I just want to point out that there's more than one possible answer, right? This happens at t equals pi, but it's also 3 pi, it's also 5 pi, it's also minus pi, dot, 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 etc., right? There's lots and lots of different things that would put us on that spot. You guys remember the word for these things that all put you on the same spot? What's that word? It's a C word. Coterminal. Yeah, all these values are coterminal, which means that they all end up at minus 1, 0. And so those are our options, right? These are all the things that give us a minus 1 x value. But we want to choose the one that's on the top half of the unit circle between 0 and pi. And so which one of those is between 0 and pi? It's the pi one, right? This is the one that's between 0 and pi. And so that's the one we choose. So let me write that down. I'm trying to be detailed here. We need t to be between 0 and pi. And so we choose this one. Right? This is the one that's between 0 and pi. And so that's the answer. And so all this is so we can say, if we want to send negative 1 back to where it came from plugging in pi. That's how we can think about that. And so kind of a common question at this point is, do I want to see all this work? I do not need to see all this stuff here. Quite frankly, I don't need to see any of it. If you have a strong, firm grasp on this stuff, I'm okay if you go to the answer. Now, I don't recommend you doing that, and here's why. If you make a small mistake, if you think you're very confident in this, but you get the wrong answer, and you have no work for it, I will have to just take all the points off. If you just write down the unit circle and maybe draw the dot and just show me what you're thinking about. I don't need to see all these words. I don't need to see all the different possibilities and all that stuff, blah, blah, blah. But just sketch the unit circle real quick. Draw a picture. Maybe make it clear that you're thinking about the x value. And then that way, if you make a small mistake, you can still get almost all the points, because I'll say, oh, well, they messed up along the way, but they were thinking about it correctly, and everything they did based on what they were thinking is true. But again, like if you just write down an answer that's wrong, I have nothing to base your reasoning on, right? So just what I'm trying to say is I don't need to see all this work, but I do want to see how you're thinking about this in some way. Questions about what I just said or this problem, this idea? All right. I'd like you to give the second one a try then. Give that second one a try. I'll set it up, right? So the way you think about the second one is you want to think, what do I need to plug into cosine to get an x value of minus root 2 over 2? Right? This is the x value on the unit circle. So you want to think about where that happens. Right, you want to think about where on the unit circle is that the x value, and then try to pick the one that's in the interval 0 to pi. Right, take a moment to think about that. I'll just say too, if you need to reference a unit circle a little bit right now, that's okay. Trying to find mine here to pull it out. Thought I had mine handy. Anyway, you have a unit circle, a completed unit circle as part of your notes. If you need to use that, go ahead and use that. But just know that you should be weaning yourself off that. All right, let's take a minute to work on this one. One last time, does anyone need test topics? This is what I was talking about. You need to look at this references sheet a little bit, that's okay. But again, you need to be able to do stuff without that sheet in the near future, so I think about not using that. Calculators too, for that matter, right? You can't use calculators on tests. You're welcome to sort of check your work while you're doing the homework. But I'm telling you right now, if you're doing the homework using a calculator exclusively, you're digging yourself into a hole. Like, it's just not helping you. So you've had a minute to think about it. Where are the x values minus square root of 2 over 2? What type of point gives us those? Pi over 4 type points have those type of values, right? And if we want it to be negative, that means it's either here or here. Those are the two places where the x value is minus root 2 over 2. Right, so there's a little more help, right? These are pi over 4 type points. So what are some options? 3 pi over 4 is an option. So those things happened at t equals 3 pi over 4. What's another option? 5 pi over 4 is an option. We could have minus 3 pi over 4 or minus 5 pi over 4. Those two are also options. And I'll just put dot, 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 etc. Right? There's lots of places, there's lots of coterminal points that might put us on that value. And we want to pick the one that's between 0 and pi. Again, right? Between 0 and pi is the one we want to think about. And so that means this top one. and the one that's between 0 and pi. So which one is that? Yeah, 3 pi over 4 is the one that's between 0 and pi. Okay, so let me write some of that down. So these are our options. Let me just be clear about it. These are our options. Those are our options. We need t to be between 0 and pi. And so we choose the one that's between 0 and pi. So in that case, we choose 3 pi over 4. And so our answer is 3 pi over 4. Okay? So cosine inverse of minus root 2 over 2 is 3 pi over 4. Because that's, if we plug in 3 pi over 4 into cosine, we get minus root 2 over 2. Right? We're doing the opposite. We're thinking about these things in the opposite direction. Questions about that? So one of the things that was brought up this morning, and I know you're still working on this stuff, and I hope after you do the homework for tonight, this will be more clear. All this stuff should be more clear. But what I want to point out, which I'm having a hard time finding this paper, I know why. So someone asked me this morning, how do I know that it's a square root of 2 over 2 is a pi over 4 type point? That was from this back in the unit circle section. These 3 points are the big ones, that are the only ones you need to know. Right? Root 3 over 2 comma 1/2, those are pi over 6 type points. Root 2 over 2 comma root 2 over 2 are pi over 4 type points. And 1/2 root 3 over 2 are pi over 3 type points. So I know that x values that have root 2 over 2 need to be some form of pi over 4. Right? I just wanted to make that clear in case you were thinking that. Questions? So let's just follow on up then. Let me just ask you a quick pop question. What if we wanted cosine inverse of positive root 2 over 2? Where does that happen? Yeah, that would be over here or here. Those are our two options where the x value is positive root 2 over 2. So it could be pi over 4 or minus pi over 4 or something like that. We want to pick the one that's on the top half, and so we would pick this one, right? And so this would be positive pi over 4. Another one to think about. All right. Can I ask any questions? Answer any questions? Can I ask any questions? I don't really have any right now, I guess. All right, let's look at the other type. These right-hand type ones. These ones are the ones that are kind of easy, but also kind of tricky. And so as a reminder, we have these two properties. These two properties say that when you plug the inverse into the function, or vice versa, everything cancels out and the x just comes out, right? So this x is the same as the x on the right-hand side. And so you just pull that number out as long as the number is in the right interval. And I'm just seeing now that there should be a 1 right here. Maybe yours got cut off too, but there should be a 1 right there. Does everyone see that? Add that in on theirs. And so we can just, in other words, minus pi over 6 is the answer to this problem as long as minus pi over 6 is between 0 and pi, right? And minus 2/3 is the right answer as long as minus 2/3 is between minus 1 and 1. And so these are the answers if they're in the right interval. And if they're not, we just have to think about it just a tiny bit more. So let's look at the first one. So this looks like this type thing, right? We've got the cosine inside the inverse. And so the answer is minus pi over 6 as long as minus pi over 6 is between 0 and pi. But is it? No, it's not, right? It's negative, and everything in that interval is positive. So minus pi over 6 is not in the right interval. It's not between 0 and pi. And so the way you do these problems are we think about what can we relate minus pi over 6 to that has the same x value that is in the correct interval. So what is something, so pi over 6, minus pi over 6 I mean, is like right here.
5 pi over 6.
So 5 pi over 6 would be over here, right? It'd be positive pi over 6, right? Positive pi over 6 has the same x value as minus pi over 6. Sorry, that kind of went off the screen a little bit. And if you look at your unit circle, you can just verify that, right? Those two both have the same x value. And so this is the same thing as pi over 6. And so let me write that down. So minus pi over 6 has the same x value as positive pi over 6. And so let's just replace minus pi over 6 with positive pi over 6. So our original problem, cosine inverse of cosine of negative pi over 6, is actually the exact same thing as cosine inverse of cosine of positive pi over 6. Again, since pi over 6 and minus pi over 6 have the same x value. And now this is in the correct interval, and so we can just pop that right out, and that's our answer. We want not a coterminal value, we want a value that has the same x value but is in the top half of the unit circle. Because a coterminal value is still not going to be up here on the top that we're thinking about, right? Any coterminal value is going to be on the bottom half. And so we're trying to think about something we can relate it to on the top half. And let me just also say this. If I ask this on the test, I may not make it as complicated as one like this. And if I did, and you told me the answer was minus pi over 6, I would still give you most of the points because to me you're recognizing the property. You didn't like translate it to the right piece of the graph we're talking about, but you knew at least the general idea of what we're talking about, right? So in other words, if you wrote that this answer was minus pi over 6, you would get significant partial credit for that. If you want full credit, we're just trying to relate it back to the piece of the graph we're talking about. Other questions or comments? What's the answer to the next one? The next one's easy. At some point, hopefully, I keep forgetting to do this. I want to like push this stuff down. I always cram this in here. So maybe someone who's watching this video in the future, you're going to have a lot more space here. Anyway, this one's nice and easy though. What's the answer to this one? Negative 2/3, right? So this one looks like the first property, and the x pops right out as long as x is between minus 1 and 1. And minus 2/3 is between those two. So this just equals minus 2/3 because that value minus 2/3 is in the interval minus 1 to 1. The next one is more what you were talking about, Eric. This is more about being coterminal. So let's look at this one. So this is, again, more like the first one. And the 17 pi over 6 is the answer if 17 pi over 6 is between 0 and pi. Is it? No. Right, so 17 pi over 6 is the same thing as 2 and 5/6 pi, or 5 pi over 6. And that is not between 0 and pi, right? It's bigger than 2, so it's not less than 1. But where is that on the unit circle? 2 and 5/6 pi. 2 pi is going around once, all the way around once, and then another 5/6 pi. So that would be going all the way around once, and then another 5/6 pi would put us right here. Does that make sense? So that's on the top half of the unit circle at least. It's on the right piece. It's just not in the right interval. And so this is a situation where we would want to think of something coterminal with that 17 pi over 6, that's between 0 and pi. And so, so what is that? What's something between 0 and pi that would also put us on that spot? So it's got to be a pi over 6 type, because we want to end up at this pi over 6 spot. But not positive pi over 6. Positive pi over 6 would be over here. So what other type of pi over 6? 5 pi over 6 would put us right there, right? It would be 1, 2, 3, 4, 5 steps of pi over 6 would put us right there. The other way to think about that is it's one step away from pi. Right, so 1 less than pi would put us right there. 1 pi over 6 less than pi. And so let me write that down. 17 pi over 6 is coterminal with 5 pi over 6. And so let's use 5 pi over 6 instead, because that's in the correct interval. That is between 0 and pi. And so we'll use that value instead. So what we'll say is our original cosine inverse of cosine of 17 pi over 6 is the same thing as cosine inverse of cosine of 5 pi over 6. And so since that's in the right interval, since 5 pi over 6 is between 0 and pi, that's the answer. All right. Questions about this page at all? Anything on here? Yeah.
So, if 17 pi over 6 ends up in the same spot as 5 pi over 6, how come that conversion works?
Okay, yeah, so good question. The reason, so technically speaking, it is the answer. 17 pi over 6 is just as good of an answer in some sense as 5 pi over 6. The reason that it doesn't quite, quote unquote, work here in this context is because we are focusing on just this piece of the graph, and 17 pi over 6 isn't on this piece. 17 pi over 6 is over here somewhere past 2 pi. See what I mean? So we're trying to relate it back to this piece of the graph. And so 5 pi over 6 is somewhere like right here, right? This might be 5 pi over 6 or something. And 17 pi over 6 is going to be down here over on this piece. And so it's on, you can see it has the same height or whatever, it's the same output in some sense, but we're just trying to relate it back to the piece of the graph we're talking about. And I know that's like, it's annoying and it's a little bit tedious or whatever, but like, WebWorks going to want 5 pi over 6 and not 17 pi over 6. And I'll just say again, on a test or something, if you tell me that the answer to this is 17 pi over 6, that's pretty good. Like if it was a 5-point question, I would probably give you 4.5 or 4.75 out of 5 or something like that. I'm just trying to be consistent and help you get the homework right, and just think about this piece of the graph. Does that make sense? Like this other piece of the graph is also 1-to-1, and that's where 17 pi over 6 lives, and we're trying to talk about this piece. Yeah. Other questions?
What if there's like a horizontal stretch?
What do you mean, what if there's a horizontal stretch?
Yeah, if there's a horizontal stretch, like the period would be longer than.
Oh, and I see, and that might actually line up with something outside that period. That's true, and in that case, if it was a horizontal stretch, we wouldn't have an x in here, we would have like a 3x or a 1/3 x or something like that. And so your answer would be scaled in that respect. In other words, the problems you'll see in the homework won't have any scaling, and if they did have scaling, you would get a slightly different version of this type of answer. So we're talking about non-scaled versions usually when we do these ones. That's a good question, though. That's a good thought, too.